students, today we are going to see another type of isomer which is known as stereoisomers. Okay, now in this topic we are going to learn the type of stereoisomers, what are the things and what are the examples comes under this. All these complete idea we are going to see to that, and it's more important. Okay, let us go for that. Stereoisomers is nothing, same molecular formula and same structural formula also, but that it differs in the spatial arrangement of atoms or groups. So that is known as what it is, stereoisomers. So stereoisomers divided into two groups, that is configurational and conformational. We are not going to talk about this conformational because it is not required for us. Configurational isomers, there are, what do you mean by configurational isomers? Exchange of two groups around one center. Exchange of two groups around one center. So that is called configurational isomers. Okay, so configurational isomers divided into two groups, that is called geometrical isomers and optical isomers are very important. There are more questions from geometrical isomers as well as optical isomers. Now, in that only we are going to see. Okay, in that geometrical isomers obtained by restricted rotation around a double bond or cyclic ring. So, where do we identify the geometrical isomers? So, geometrical isomers generally we can get it from alkene, oxime, diazo compound, and cyclic alkane. Hope as you got an idea, it is obtained by the restricted rotation around the double bond and cyclic ring. So in that way you can identify the geometrical isomers. So as we are going for the examples, you will come to know what it is geometrical isomers, how to identify, what are the examples are available, how many isomers are available in each compound, like that, all those tricks we are going to see to that. Okay, now let us go for that to identify all the geometrical isomers and optical isomers. First and foremost, we'll go for geometrical isomers. In that cis and trans isomers, all those points we are going to see to that. Okay, now in the geometrical isomers examples, generally alkene, okay, alkene and oxime, diazo compounds and the cyclic alkane. So number of carbons will be more in that point. Okay, please note down. Hope you're clear with that. Okay, we'll go for that examples so that you will come to know very clearly. If you want, you can take that screenshot. The next one we are going to see cis and trans isomer. How to identify cis and trans isomer? Okay, now let us go. What do you mean by cis and trans isomer? If two identical groups of each double bonded carbon on the same side, then it is known as cis isomer. Or else, but if they are opposite side, that is trans isomer. Generally, examples will get that better idea and will get it confident also. Come on, let us go for the examples. Now the first example, C, double bond C. Okay, now one side Cl I put it, the other side hydrogen. The same way Cl and hydrogen. Okay, now what they mention, if two identical groups of each double bonded carbon on same side, then it is known as cis isomer. Okay, now that means this is cis isomer. Now the same way trans, C double bond C. Now one side hydrogen, the other side hydrogen. Now this side here Cl and here Cl. Just ulta, just you rotate this side, so automatically this hydrogen will go up, this chlorine will come down. Just to one side, just to the opposite, like this. If we, this is cis isomer, this is trans isomer. Okay, now cis isomer, trans isomer. In that way we can identify. So this is cis and this is trans. Okay, one more example. Okay, now here C double bond C. Here one side CH3, the other side hydrogen. The same way here CH3, here hydrogen. That same cis and trans. Now by this time you will come to know trans how. It's so simple. Here hydrogen, here one hydrogen. Just crisscross like this. Okay, now here CH3 and here CH3. Okay, hope you're clear with this. Okay, now one more example we can go for it. The same thing. Here, C, double bond C. Here, one side hydrogen, one side COOH. The other side, here, hydrogen, here, COOH. So, both the side are same. So, the other one opposite, by this time, you will twist. So, C, double bond C. Here, COOH. Just to the opposite side, COOH. Now, here, hydrogen, here, hydrogen. Now, I think you will come to know the better idea about that cis and trans isomer. Is it clear? So, which is cis and which is trans? This is cis and this is trans. Trans, just that turn, what it is, exchange of that group of atoms. That is called trans. Cis, that means each double bonded carbon atom on the same side. So this is what it is, the same side. That is called cis. Hope you're clear with this. Okay, now which is not for that cis and trans isomer. Suppose if they are giving one formula, whether it is possible or not, let us go and identify. Okay, now this is cis and trans, you will identify. Now suppose here C double bond C, here one hydrogen, here one Cl. Now both the side CH3, CH3. Okay, do you think that this is possible for that cis and trans isomer? Okay, now one more example also. C, double bond C. Here one hydrogen, the other side also one hydrogen. Here CH3 and here Cl. Okay, now these two compounds, whether is it possible for cis and trans isomers? Is it possible? Now both the side are same, but here both the side are opposite. Now generally, see, like this it has to be. See, both the side it should be equal. Opposite side trans. See, so in that way it should be same. What it is, same side. The identical groups should be same side. So that is the way we can identify cis and trans. Now, which is possible for cis and trans, which is not possible for cis and trans. Hope you're clear with this. One side it is possible, the other side it is opposite. The same way here, one side it is possible, the other side it is. Okay, now you are able to identify cis and trans, whether it is possible or not also you will come to know. Okay, now the next one we are going to see. The next isomer, it is syn and anti-isomer. Okay, that is from geometrical isomer only. Geometrical isomer we have gone through cis and trans. The other one, it is syn and anti. Okay, now in this, what purpose we are using? To indicate that hydrogen and hydroxyl groups are present on the opposite side of the double bond of the carbon. Okay, now easily we can identify. Okay, C double bond C. Here one side hydrogen, the other side CH3. Okay, it belongs to what it is, aldoxine. And one more thing, diazo compounds also we can identify syn and anti. Geometrical isomer. Okay, one side here OH and here nitrogen, lone pair of electrons. Okay, now the same way opposite side C double bond C. Here what it is OH, that means this side H, and here CH3, and here what it is nitrogen, lone pair of electrons. Okay, so this is syn and this is anti. Okay, now the other one will give for another example. The same way, C double bond C. Here pH I will put it. pH and here H. The same way nitrogen and here OH. Just that same idea. Okay, now here the same way. Just by this time you will come to know how to put it. Okay, both the side. This is hydrogen and this is hydroxyl group. The same way, C double bond C. Here OH will be coming, here nitrogen. Okay, now this is what it is, pH, and here hydrogen. Okay, in this way, this is what it is, syn, and this is anti. Okay, now diazo compounds also we can, this is what it is, same side, this is same side, this is opposite side. Okay, cross, opposite side. So easily we can identify. Okay, now diazo compounds we will go for it. N double bond N, one side it is pH, the other side also it's pH. Okay, both the sides same. Then here lone pair of electrons, here also lone pair of electrons. Okay, this is diazo compounds. Okay, that just to the opposite what it is, the same way, N double bond N, one side pH, the opposite side pH, and here lone pair of electrons. Okay, and here also lone pair of electrons. So in this way, this is syn. So both the sides same and both the side opposite, and T. Easily we can identify. Okay, now in the same way, now this is what it is, aryl group. Now alkyl group also we can go for it. N double bond N. Here one side CH3, other side lone pair of electrons. The same way here CH3, here lone pair of electrons. Just to the opposite, you will come to know now by this time. N double bond N, this side CH3, then this side CH3. And here lone pair of electrons, here lone pair of electrons. So the now what is this? SYN. What it is? Syn and P. Okay, hope you're clear. Now, what purpose we are using syn and anti-isomers? To indicate that what it is, hydrogen and hydroxyl groups present on the opposite side of the double bond. Okay, hope you're clear with this. This is diazo compounds, and the first one what we have gone through, it is syn and aldoxime we have gone through. Hope you're clear with it. Okay, now the next one more thing we are going to see. Here, calculation of geometrical isomers in polyenes. It's very important question. Okay, so there are 3 points to be noted. Now, one by one, we will go for that. There is a small trick to identify how many isomers are possible in one compound of geometrical isomer. Okay, now let us go for that. Okay, now polyenes. What do you mean by polyenes? Number of double bonds in one compound. Okay, so that is called polyenes, alkene. Okay, now in that, if both the ends of the polyenes are different, okay, how to identify? Now pH, it is a phenyl group, CH double bond CH, CH double bond CH, CH double bond CH, and CH3. Okay, now both the ends are different, both the ends are different. Okay, now in that, how to identify how many isomers are possible in the geometrical isomers? Okay, number of geometrical isomers equal to, and I'll give one formula, 2 to the power of n. N, it is what it is, number of double bond, number of double bonds. Okay, now next one. Now how to identify number of double bonds here? 1, 2, 3. Okay, so number of geometrical isomers. How many isomers are possible? Here 2 to the power of 1, 2, 3. So that means 2 into 2 into 2. So altogether how many? 8. So in this compound, suppose if they are giving such kind of compound, if both the ends are different, both the ends of polyenes are different, so how to identify? So in this way you can identify, you can use this formula to what it is, 2 to the power of n. It is what it is, number of double bonds. So how many double bonds are there? 1, 2, 3. So in that way you can identify. So 8 isomers, 8 isomers. Which isomer? Geometrical isomers are possible. Okay, now the next one we are going to see, even number and odd number. Okay, so both the ends are different, we have gone through. Now we are going to see both the ends are same, as well as we are going to see even number and odd So these are the points we are going to note down. The next case, if both the ends of polyenes are same and even number of double bonds. So what is the formula we are using? Okay, always formulas and tricks tips will help us to get that more ideas and confident with that answers. Okay, now here that both the ends are same. CH3 will take it. CH3, CH double bond CH, CH double bond CH, CH double bond CH, CH double bond CH, CH3. Okay, now both the ends are same. Both the ends are same. And the double bonds, how many? 1, 2, 3 and 4. Yes. For this, what is the formula? Use it. Number of geometrical isomers is equal to. So here what we can say? Here 2 to the power of n minus 1 plus 2 to the power of n by 2 minus 1. So this is the formula we can utilize to find out how many geometrical isomers are possible. Okay, now according to that number of geometrical isomers, here 2 to the power of n minus 1, how many? 4 minus 1. So 1, 2, 3, 4, 4 double bonds are there now. So n it is what it is? Number of double bonds. So n it is 4 double bonds are there. 4 minus 1 plus 2 to the power of n by 2. So 4 by 2 minus 1. So what is the answer? You will get it 2 to the power of 3 plus 2 to the power of here 2 minus 1. 2 minus 1 that means 1. So here 2 to the power of here 8 plus here 2. 2 to the power of 1 only you will get it. So here altogether 10 isomers are possible. 10 isomers. What isomers? Geometrical isomers are possible. Hope you're clear with this idea. See now what is the formula we are using, what purpose we are using. Hope you got a clear idea on how many isomers are possible. In that way, definitely they will ask one among four option. In that they will ask such kind of question. If both these are all to identify the answers, I'm giving the tricks for you. Okay, now we'll go for the sums. These are all tips for you to understand the concept. Then we will go for the objective type questions. Hope you're clear with it. Okay, now this is what it is. If both the ends of polyenes are same and even number of double bonds, for that you have to use this formula and you got that idea. Hope you're clear. Okay, now the same way here, odd numbers we are going to see today. Then next one more thing, if both the ends of polyenes are same and odd numbers of double bonds, so how to identify? One point it is the same ends, both the ends are same and odd numbers of double bonds. Yes, let us go for it. Now pH we can take it, CH double bond CH, CH double bond CH, CH double bond CH and pH. Okay, both the ends are same. Then second one, here double bonds. How many double bonds are there? 1, 2 and 3. Odd numbers. Now what is the formula we are using to identify how many number of geometrical isomers are possible? Okay, number of geometrical isomers equal to here 2 to the power of n minus 1 plus 2 to the power of n plus 1 by 2 minus 1. So this is the formula we are using to identify for this compound how many geometrical isomers are possible. Yes. Okay, let us go for it. Here now to the 2 to the power of n. N it is what it is. Number of double bonds here 3. 1, 2, 3 only, no. 3 minus 1 plus 2 to the power of 3 plus 1 by 2 minus 1. Okay, now here 2 to the power of 2 plus here what it is 4. 4 here 4 means what it is here 2. 2 minus 1. 1. Okay, so that means here 4. 4 plus 2. 6 isomers. 6 isomers are possible. Which isomer? geometrical isomers of this compound. Suppose these both the ends are same. If odd number of double bonds are available in that compound, so you have to use this formula. Which formula? Here 2 to the power of n minus 1 plus 2 to the power of n plus 1 by 2 minus 1. Okay, now this for what purpose we are using? To identify number of geometrical isomers for respective compound. For that purpose we are using. Hope you're clear with this ideas. 3 cases we have gone through. Hope you're clear. Okay, now next one, what is it? Chiral center. Chiral center, it is nothing. A carbon atom bonded to 4 different carbon atoms or groups in a molecule is known as chiral. Okay, so carbon which is connected to that 4 different atoms or groups, that is called chiral. Okay, now here what it is? C3H7 and then C2H5 and then hydrogen here CH3. So this carbon which is present in the center, so that is called chiral carbon. A carbon atom which is bonded to the 4 different atoms or groups in a molecule is known as chiral center. Okay, I'll give one more example. Here carbon, here OH, here hydrogen, here NH2 and here what it is? Cl. Okay, now another one more example. Like different examples will get that better idea. Okay, now here CH3 and here Br. So this asterisk I just mentioned, this point which is called chiral carbon. Okay, now one more example. 1, 2, 3, 4. Here pH and here OH and here Cl and here. Okay. Now such kind of, how many chiral centers are available? Okay. Now in this this point which is chiral and this point which is chiral and this point which is chiral. So in this way we can identify the chiral carbon. Hope you're clear with this. Okay, how many chiral centers are here? 1, 2, 3 and then here in this way. So easily you can identify what is chiral. Okay, now why do I bring this point over here? No, this will come an optical isomer. Now we are going to see that only. That is what I brought it here. I am giving a brief idea for each and every point to identify the answer for the questions. Hope you're clear with this. What is chiral center? Okay, now we are going to see optical isomer using this. Hope you're clear. The next one, it is optical isomers. Optical isomers, which is very, very important. Chiral, it is very important. What do you mean by chiral? A carbon connected with different groups or atoms. Okay, now let us go further. In order to exhibit optical isomerism, an object or molecule must be chiral. So definitely the first eligibility for optical isomerism, the carbon should be chiral. The chiral molecule should be available. The chiral molecule should be there for it. Okay, any molecule is said to be chiral if it does not have POS and COS. What is it? POS and COS? Plane of symmetry and center of symmetry. It should not have plane of symmetry or center of symmetry. Why? When you cut, it will be same. Okay, so that is the symmetry. So plane of symmetry, center of symmetry, it says that only. Okay, so it should not have plane of symmetry and center of symmetry. How is it possible? Because chiral is having 4 different groups, right? So it does not have the plane of symmetry and center of symmetry. A chiral molecule non-superimposable, that is very important, non-superimposable on its mirror image. So these are the points to be noted for that optical isomers. So whenever you are checking that formula or molecule, these are all the points to be noted whether it is possible or not. Okay, I'll give one example. Here CH3, here H, here Cl, here OH. Okay, mirror image, superimposable. Okay, now the same way here OH, here CH3, here hydrogen, here Cl. So this is the way you can identify whether it is possible or not. Now one more example, the same way. Here carbon and here CH3, here C3H7. In this, here hydrogen, here C2H5. Okay, in this point, just the opposite. Okay, here carbon CH3, here C3H7. Now here hydrogen, here C2H5. So these are the way we can identify for optical isomers. So as we are going for optical isomers, we are going to see the enantiomers and what it is, chiral, antichiral and plane of symmetry. Everything we are going to see to that. Hope you're clear with that optical isomers, and some more ideas also I would like to give you. Now, how to identify that POS? That is nothing, plane of symmetry. Plane of symmetry is a mirror plane that cuts a molecule of half so that one of the molecule is a reflection of other. So easily we can identify with the example. Now for example, here C double single bond C, here CH3, here hydrogen, here Cl. The same way here CH3, here hydrogen, here Cl. Okay, now we are going to cut with that. So that is a mirror reflection of the other one. Okay, now one more example. Okay, now here what it is, OH, single bond only. Here, I just put it OH. So okay, when we cut it, that is the mirror image. Okay, now another one. Carbon connected with the hydrogen, here Cl, here CH3 and here CH3. When we cut, what happened? Both the side. This may be opposite, but here. So this is a mirror plane which is not possible for the optical isomer. Okay, one more example. This side CH3 and this side NH2. Okay, when we cut this side, both the side. So this is actually what it is, mirror plane, reflection of the other one. Okay, see this side and this side, both are same. And this side and this side, same. Okay, and this one. So easily we can identify plane of symmetry. When you cut the apple, both the side, it will be similar. Hope you're clear with this optical isomers with that plane of symmetry. Plane of symmetry only I'm giving idea about that. Hope you're clear. Okay, now we are going to see that enantiomers. Before that, achiral I'm going to introduce it. Hope you're clear. Now, which of the points to be noted for POS? What is it? POS, plane of symmetry. The first one, achiral molecule. That is achiral. Achiral just to the opposite of chiral. Chiral, it is having different kind of atoms in one center of carbon. But here, achiral means same kind of atoms or groups which is attached to that carbon. So, achiral molecule contains POS, plane of symmetry, but chiral doesn't. Yes, chiral it will not. Okay, and next one, with no stereogenic. See here, stereogenic is nothing, chiral only we are mentioning. Stereogenic is another word of chiral, please remember, because to confuse they may give this word also, so I am telling this point. Okay, with no stereogenic center chiral, some of the exceptions will be possible for what it is, plane of symmetry. So what are those? So here allene, biphenyl and spirans. So these are all possible for even if it is chiral, even if it is stereogenic center. So in this place, these are the exceptions for that, what it is, POS, plane of symmetry. And next one, here with two or more stereogenic center, with two or more stereogenic center, more than one chiral atoms are available, more than one chiral carbon is available. That means a molecule may or may not be what it is, chiral. We cannot mention in that is actually that may or may not be what it is, POS. Okay, hope you're clear with this idea related to this point, because why I'm giving all these points, no, that will be helpful for you to crack out the sums. That is what I'm giving all these ideas. These are all comes under what it is, plane of symmetry. Now we are going to see enantiomers. Hope you're clear. Enantiomers are very simple. Enantiomers isomer which are mirror image that are not superimposable, known as enantiomers. Okay, now one more way we'll tell. A pair of molecule that exist in two forms that are mirror image one another but cannot be superimposable one upon the other. Okay, so in that way we can identify. Okay, now here CH3 in this, here pH, here Cl, and here hydrogen. The same way here CH3, here pH, here Cl, and here hydrogen. So this way we can identify what it is, enantiomers. One more example also we can say. Here CH3, here CH3, and here OH, here H, here Br, here H. The same way here this side CH3, CH3, and here OH, here H, here OH, H, here Br. Okay, in this way we can identify. And one more thing, enantiomers having that chiral center. Enantiomers are having same physical property, chemical property, viscosity, boiling point, melting point, everything same, except what it is, rotation of plane polarized light. Okay, enantiomers are also having a chiral center. Hope you're clear. The equal amount of that enantiomers are known as racimic mixture. So these are all the points. It's actually an idea for you to get that what it is. Objective questions answer to identify. These are the points. That is what I just given a brief way to identify all those things. Okay, next session we are going to see all those related objective questions related to this topic, isomers, because that is two pillars are there in organic chemistry. One, it is organic mechanism, that is very very organic mechanism reaction. The other one, it is what it is, isomers. Okay, now in that some questions we will go through which is related examination oriented questions, we will see to that. Then reaction mechanism also is another point. Okay, hope you're clear with it. Racemic mixture, equal amount of enantiomers is known as racemic mixture. Okay, now we'll get some ideas from plane polarized light. There also some tricks and tips are there. Let us go for it. The next one, diastereomers. See, all these points and all, I'm giving a brief idea to analyze the question. Okay, now diastereomers, the isomers which are not mirror image is known as diastereomers. Okay, example CH3 here, C2H5, and here OH, here H, here Cl, the same way here H, the same way here CH3, here OH, here Cl, here H, here H. Okay, not, it's actually a diastereomers. One more example also we can give. C double bond C, here CH3, and here CH3, here H, here H. Just to the opposite side, here C double bond C, here CH3, here CH3, and here hydrogen, here hydrogen. Okay, so these are all diastereomers. They are not mirror image. Do you think this is a cis and trans? Yes, it may. It is possible. Okay, now come to this because everything one related upon others. Okay, now the next one, meso compounds. How to identify meso compounds? Achiral compounds. Chiral means you know very well. Achiral just the opposite. Okay, achiral compounds that contain a plane of symmetry or center of symmetry. COS, it is center of symmetry, known as meso compounds. Why I am giving all these ideas? Because to identify the stereomers, number of stereomers, how many stereomers are possible in certain compound. In that way, you have to identify that meso compounds are available and diastereomers are available. That is what I am giving all these brief idea for you. Hope you're clear with this. Now, enantiomers and mesomers will get the best example. Here, C single bond C, here CH3, here CH3. Okay. Now, here hydrogen, here Br, and here Br. Okay, this is two identical, what it is, one compound. Okay, now in that two halves of identical compound, in that how to identify that enantiomers and mesomers, let us go for it. Okay, enantiomers, C double single bond. Okay, C single bond C, here CH3, here CH3. In this hydrogen, here Br, here Br, here hydrogen. Okay, now the same way here, carbon connected with carbon, here CH3 and here CH3. Okay, now here in this, now the same way here, okay, H Br, the same way here hydrogen Br. Okay, now these 2 points are showing that enantiomers. This is part A and this is part B. Okay, this is what it is, enantiomers. Now, meso compound. Here meso compound, carbon connected with carbon. Here CH3, here CH3, and here hydrogen, here Br, and here Br. Okay, so this is meso compound. Okay, now this A and B are diastereoisomers of C. Okay, A and B are diastereoisomers. Diastereoisomers of C. This is C, diastereoisomers of C. Hope you're clear with that. Enantiomers, mesomers, actually this is a compound in that we are going to see to that. Okay, now we are going to see one small calculation part which is related to the stereoisomers. Okay, now the next important trick to find out isomers. Suppose if they are giving a compound, how many stereoisomers are available? Such kind of question. There is a small trick. So let us go and identify. If a compound does not contain POS, plane of symmetry, that means it's a asymmetric carbon. That means it's a chiral center. Okay. Now number of stereomers. Okay. Number of stereomers. Stereomers or stereoisomers both the same only. So 2 to the power of n. N, it is what it is, number of chiral carbon. Number of chiral carbon. So chiral carbon means you know very well what is it, chiral carbon. Okay, now the next one here. Now here example, I'll give one example. Here C2H5, here C, here OH, here H, here the same way here OH, here H, here C2, CH3. Okay, now I am giving this formula. Okay, now in this, how many chiral carbon is available. As you are looking only, you will come to know this is one carbon. In that carbon connected with that OH, and here one hydrogen, here C2H5, here completely one set of group. So that means this is one chiral. The same way here also. Here C, this carbon connected with the H, here OH, here CH3, this completely connected with another group, this complete. So that means this is also another chiral. What do you mean by chiral? Chiral means what it is? Different groups or atoms attached to one carbon. So there are two chiral carbons are there. So number of chiral carbon, it is 2. So what is the formula here? 2n squared. So here in this compound, number of stereomers equal to 2 to the power of n. N means what it is? Here 2, right? So 4. So 4 stereomers are possible. For this compound, how many stereomers are possible? 4 stereomers are possible. Hope you're clear with this idea. If a compound does not contain plane of symmetry, that means asymmetric, number of stereomers, if they are giving that idea, if they are giving that any compound, can you identify that how many stereomers are possible with this example along with this formula? Hope you're clear. Okay, we'll go for the some other sums. Next, one more. If a mesoform compound appear, meso means it will be same. Already I just mentioned in that way. Okay. So meso means it is the same. Now, what is the formula can you use? 2 to the power of n minus 1. N it is what it is, number of chiral carbon. Okay, now I'll give one example so you will come to know. Here, carbon connected with CH3, here OH, here H, here the same way, here OH, here H, here CH3. Okay. Now in this, how many chirals are available? This is the carbon. See, in that meso compound, what do you mean by meso compound? Same kind of two halves. Okay, so that is only meso compound. Please remember, same kind of two halves, that identical two halves, it is what it is, meso compound. Yes. Now, in that way, how many chiral is available? Carbon connected with OH, hydrogen and CH3. This another point which is a complete group. Okay, the same way here, this carbon connected with OH, H, here CH3, that complete set of this. Okay, now this, that means here two chirals are available. Now here, what is the formula? Can you give that? 2 to the power of n, that means here 2 minus 1. Okay, so that means how many? 4 minus 1. So that means 3. So 3 isomers. So 3 stereomers, you can bring it from this formula. How many stereomers is possible? Number of stereomers. Stereomers, it is 3 stereomers, suppose if it is in meso compound. And yes, hope you're clear with this idea about this point. Okay, we'll give some other sums related to this topic. Now let us identify how many stereomers are possible with this compound. Okay, first one, here carbon connected with the CH3, BR, H and CH double bond CH2. Okay, first and foremost, what is that formula? 2 to the power of n. N it is what it is? Chiral, number of chiral carbon. Okay, now let us identify which is the chiral carbon. This carbon connected with the CH3, BRH and CH double bond CH2. Yes, this is a chiral carbon. Whereas here, this carbon, is it a chiral carbon? That means here carbon, no, double bond. Now that means here, this is not a chiral carbon. It does not have that chiral carbon. So, and one more thing, for the main condition for the chiral carbon means chiral carbon should have sp3 hybridization, whereas here sp2 hybridization, this also sp2 hybridization. But generally here tetrahedral sp3 hybridization only, because carbon connected with four different groups or atoms. That means carbon has that four valency, four different groups. Each and everything will be everything different. So that means sp3 hybridization only it is possible. Double bond and triple bond will not be possible for this compound. Okay, so how many stereoisomers are available? That means how many chiral carbon is available for this compound, means only one chiral. So that means 2 to the power of 1. So how many chiral compound is available? Means here two compound only available, two stereomers only available. Okay, now let us go for this formula. Okay, now as we are looking at this, chiral is the main condition. What it is? Four different groups attached on that carbon. That means here both are same. In that first point only gone. So that means there is no chiral. No chiral. So in that way you can identify. Okay, now here the same formula only I just mentioned here Br. Here CH2, one hydrogen has replaced by Br. Okay, now how many isomers, that means stereomers may be possible? Okay, now that same way, that means this is not possible. Stereomers number of carbon, that is a chiral actually null. But whether it is possible for any isomer means, okay, hope you're clear with it. Let us, yeah, I will write it here only. So in this, here CH3, here C, here CH3, here hydrogen, here carbon connected with the hydrogen and a double bond, here carbon connected with H, here Br. Okay, as you are looking this hydrogen and this hydrogen, it is opposite side. Opposite side means what it is? Trans will be available. That means trans is there means there will be cis also. So where you will put it cis, I just put it here. Carbon connected with the CH3, this CH3 and this hydrogen here. This carbon connected with the hydrogen, here carbon double bond. Carbon connected with the hydrogen, here what it is? Br. Okay, so both the side are same. So that means here cis. This point you can bring it what it is? Cis. So cis means both the side hydrogen. See, one carbon which is connected, this carbon completely connected, this group completely connected with this point. The same way, this group it is completely connected with this point. Is it visible? This group completely connected with this. Okay, this is cis isomer. Okay, hope you're clear with this. So how many isomers are possible? It is not stereoisomers. How many isomers are possible? Means cis and trans isomers are possible. Hope you're clear with this compound. Okay, I hope you got a complete idea about that all stereomers. Now next session we are going to see some questions related to that isomer, so that you will be thorough. As you are looking at the question, you will get that confident. Hope I just bring it to your notice, trans and cis very clearly with this formula, whether it is possible or not. Here, chiral carbon, there is no chiral carbon. But slightly I changed, instead of CH2, one hydrogen is replaced by Br. So naturally, you are forming a cis and trans isomer. Yes, this is a trans isomer, just to the opposite. Here, cis isomer, same side. Hope you're clear with this idea. I just bring it to you. Hope you're clear. Okay. In our next session, as I mentioned, we'll follow some questions related to this topic. I hope this is a lengthier topic only, but somehow I managed and I have given all important points to be noted for you all. Hope you understand all these points. Thanks for watching.